In a fascinating recent development, the Hawaiian volcano, Kilauea, is actively erupting as I bring you this story. Welcome friends, Dr. Jim Daly of Astronomy for Change here, your host, bringing you this breaking story. This volcano has been in almost continuous eruptive state for about 40 years, and in this latest development has sprung back to life with the most recent eruption of December 21st, continuing through today and reminding everyone that the Earth is quite alive. Historically, Kilauea is the most active of the 5 volcanoes that together form the Big Island of Hawaii. Located along the southeastern shore of the island, the volcano is between 210,000 and 280,000 years old and emerged above sea level about 100,000 years ago, with the volcano's most recent eruption occurring on December 21st of last year, 2020. Residents of the large island, home to a major astronomical observatory atop Mauna Kea, a dormant volcano, one of the 5 that form the Big Island, and the future home to the 30-meter telescope. As we look at these rivers of lava, along with researchers from the United States Geological Survey and the Hawaiian Volcano Observatory, located on the large island of Hawaii, molten rock emerging from the enormous wall of magma below, we're reminded that the Earth is an active planet and quite alive. So what is the source of all this heat? Is it from the primordial fires of creation? As we know, planetary formation is the byproduct of star formation, with our sun and solar system forming over 4.5 billion years ago from the interstellar medium, the cold gas and dust between the stars. Gas and dust enriched with the byproducts of nuclear fusion, elements forged in the nuclear cauldrons of long-dead stars. These byproducts include heavy elements such as potassium, thorium, and both species of uranium, U-235 and U-238, all with very long half-lives. Potassium-40 has a half-life of 1.25 billion years, uranium-235 704 million years, uranium-238 4.5 billion years, and thorium-232, the longest of them all, with a half-life approximately equal to the current age of the universe of 14 billion years. What is a half-life? Half-life is the time it takes for half of the original complement of that particular element to decay to 1/2 of its original value. So if we start out with 2 kilograms of thorium-232, it'll take approximately 14 billion years for that to degrade to 1 kilogram of thorium-232. This is why the Earth will remain an active planet for billions of years to come. Aside from the leftover heat remaining from the Earth's formation, the heat produced by the radioactive decay of these elements is the principal source of Earth's internal heat. It should be pointed out that these heavy elements, with the exception of potassium, are from the actinide series of nuclides, were formed in the violent aftermath of a supernova, the spectacular end state of a high-mass star. So what we're looking at is, indeed, the primordial fires of creation. The energy that went into binding these heavy nuclei together during the spectacular death of a high-mass star is being slowly released in the depths of the Earth, and thus giving life to our planet. This is perhaps the greatest expression of the cycle of life. With death comes new life. Earth consists of a solid iron core, a semi-liquid outer core comprising approximately 1/3 of its radius. This is followed by the mantle, imbued with magma, the molten rock below the Earth's crust, a paper-thin by comparison layer upon which float the 7 major tectonic plates. It is at the boundaries or intersections of these plates that we usually find volcanoes or the sources of earthquakes. Unlike the stereotypical image of a volcano characterized as a cinder cone or stratovolcano, Kilauea is in a class known as shield volcanoes, volcanoes formed by repeated eruptions or outflows of highly liquid lava. So where else do we observe shield volcanoes? On Mars, Olympus Mons, Mount Olympus, along with 3 lesser volcanoes located on Mars' Tharsis Plateau. Olympus Mons is the largest and highest known volcano in the solar system, with a height over 20 kilometers, 3 times that of Mount Everest, with an area larger than the geographical land area of France. Here we see the Halemaumau lava lake depth compared to the Empire State Building. This is the Kilauea volcano summit eruptive activity as of 11:44 a.m. on the 23rd of December. Here we see the 3D rendering of the volcano. And here the volcano, here the Empire State Building. This is what it would look like, or scale compared to the lava lake. The United States Geological Survey has live webcams stationed at this summit here. And this was the image as rendered, as recorded on December 27th, just after 6:30 a.m. Hawaiian Standard Time. Here we see the volcano, a rendering, a scale rendering of the summit of the volcano's depth in meters. The dark red is 150 meters, and up here is 0. So as we go down into the mountain, down into the crater, we'll get it going down to a maximum depth of 150 meters. Here's a view looking into the crater after the whole surface, the whole floor of the lava bed collapsed down on the caldera. The caldera is the open crater. Here, it's a better image. This image was recorded within the last 24 hours at the volcano, so it's active. In the description, I'm going to leave links to all this content, the United States Geological Survey, and the Hawaii Volcano Observatory. Here we have Google Earth. Here's Google Earth. Let's find our volcano. Okay. You can see the shield structure here of the volcano. Zooming in closer. Here's Mauna Kea over here. Right here, Mauna Kea. That's the location of the world-class astronomical observatory, soon to be the home of the 30-meter telescope. 13,000 feet is the elevation here. Now Let's hop on over to Mars and let's take a look at Olympus Mons. Here's Olympus Mons on Mars. Here it is. It's the giant shield volcano, the largest one in the solar system. Now, why do you suppose that Mars is home or host to the largest shield volcano or the largest mountain in the solar system? Is because of the lower gravity allows things to get taller and bigger. Okay, less gravity, the more the taller something can be. It's not going to get crushed under its own weight. And here are the three lesser volcanoes in the Tharsis region of Mars. Here. These three right here. Now, if you're interested in this application here, this is Google Earth. The only way you can get to see Mars rendered as such, or the Earth rendered as we did, and even the Moon. Here, you can see the Moon, is to install the active desktop, the Google Earth desktop, not the web version. Okay, this is the Moon. This is our Moon, available through Google Earth. Pleiades out here. So, returning to the Earth. You can see a similarity between this structure right here, and what we saw on Olympus Mons on Mars. And this is Hawaii's Volcanoes National Park, adjacent to the caldera over here. I hope everybody found this video educational and informative. If you did, please like, subscribe, and share. And as always, please leave your comments and suggestions in the comment section below. The great philosopher Plato famously said, "Astronomy compels the soul to look upward and leads us from this world to another." Astronomy for Change is a non-profit organization whose mission is to effect positive change through astronomy and science education. It is our belief that by inspiring and empowering current and future generations to become interested and engaged in astronomy and science, this positive change will be realized. If you found this video helpful and educational, please like, subscribe, and share. Also, why not consider supporting us on Patreon? Head over to our homepage, astronomyforchange.org, click Support Us via PayPal or Patreon, and choose a membership level suitable for you. Every little bit helps us produce the great content and further our mission. Also, why not consider becoming a member? Membership is free at Astronomy for Change. Choose the membership link here, click it, put your name and your first name and your email, and you'll be added to our list. You'll receive a comprehensive digest of all our videos and articles and all our great content. Joining and becoming a patron helps us grow and improve and more fully realize our mission. Thank you. This is Dr. Jim Daly for Astronomy for Change. Until the next video, please stay well and keep looking up.